Benvenuti.
I'd like to thank the Società Geografica Italiana. Today is represented by Professor Gianluca Casagrande, who will tell us why we are here, and he will tell us more about this palace. Most Romans just know the gardens rather than the palace. So we will have the opportunity to listen to the different guests, and I thank you for choosing to be here on a Friday morning, and also like to thank those who are connected online. So the streaming will be in the language spoken on the stage, and so sometimes English and so English or Italian. In the next few days, we will add the Italian and English translation. So here we have the translation. So if you need interpretation, you can use the headset. So everything is in order. We have the headsets for the different speakers here. So now we will start with a different with a connection from the first representative of the government, Mr. Mascaretti, President of the Parliamentary Intercommission on Space Economy. So thank you for being here with us. Good morning.
Buongiorno a tutti. Il mio saluto arriva da remoto, ma come arriverà, credo, presto anche sulla Luna, no? Visto l'argomento che stiamo trattando oggi. No, voglio portare un saluto, voglio ringraziarvi per quello che state facendo, perché l'economia dello spazio è una grandissima opportunità, ovviamente dal punto di vista economico per il nostro paese e per l'Europa, ma lo è anche dal punto di vista sociale e ambientale. Quindi si aprono scenari completamente nuovi e forse inimmaginabili fino a pochi anni fa, e credo che la scienza, la tecnologia e l'economia ci spingano molto oltre a quello che probabilmente le persone che non sono addetti ai lavori oggi sanno. Quindi anche offrire un'opportunità di incontro come questo e poi renderla disponibile.
So it's important that this conference is broadcast live on streaming for those people who want to have more information on this very important topic. As you know, Italy has just approved the first law for economy and space, which is the first Italian law and the most modern law we have in Europe and in the West. So it's something extraordinary. We have just implemented the second edition of the Central States of Space Economy. It's a reality which is moving very, very fast, and where Italy is a great protagonist. You know, Italy is implementing the modules of the lunar project, and Italy signed the first agreement with the Italian Space Agency to implement the first housing module for astronauts, which will be placed on the moon. And so Italy is the protagonist of this great challenge. The moon has a very important surface, almost 38 million square kilometers. So if you calculate Africa as 30 million square kilometers, you can imagine what it means to send rovers to the moon without a geolocation capacity, or perform great operation on the moon without a direct telecommunication system. So every time you have to bring the antenna and manage the communications between Earth and moon. So it is a geolocation system similar to the one on the Earth, which will make it possible to make important steps forward to implement production, extraction facilities for the launch platforms for missions to the space and Mars. So this is a very important moment. This telecommunication platform for lunar geolocation is a first step, but it's extremely important. So thank you for the event you have organized today. I wish you a fruitful conference, and I will be connected online. So thank you.
Grazie molto onorevole per la sua disponibilità e buon lavoro a lei.
Thank you so much.
Abbiamo detto che
So as we said, not all Romans know this place, and so we call a representative of the city hall. So I'd like to ask Riccardo Corbucci, President of Roma Capitale Commission, Statuto Innovazione, to give us his welcome speech. Thank you for the invitation and for choosing such a beautiful and extraordinary place for this important meeting, which follows what we have been trying to build in our city. And in the metropolitan city, there are so many investments on innovation, technological innovation, but also social innovation. And we want to create a sustainable, we want to promote the sustainability of our regional system. And of course, Roma Capitale is a fundamental part of it. We know that in 2026, Rome will be European capital of space, and this will be a great opportunity to strengthen the presence of Rome at national level on this topic, but also to enhance the area, metropolitan area of this city where we have important research centers. This is a city where we have public and private universities which contribute to the production of our young students and researchers on whom we have to invest, and also the possibility of regenerating the places of our city and to make them places where we can build knowledge and bring investments. And so we are supporting this great transformation, and as the previous speaker was saying, I believe our country is playing a central role at European level, and Rome is a driver for the rest of the country, and wants to be, the institutions wants to be next to the companies that invest in this sector. So thank you, and I will be here listening to all of you.
Grazie molto. A questo punto chiediamo.
Thank you so much. So now I'd like to ask Professor Gianluca Casagrande, Professor of European University of Rome, Professor of Geography, Explorer, member of Società Geografica Italiana, to welcome us all. So, Professor, you have the floor. Good morning, everybody. Welcome to Palazzetto Mattei. I'd like to thank Namex, the organizers, and my friend Cinetto for inviting me. Well, unfortunately, I will have to leave after my speech, but we have an emergency to solve, and unfortunately have to leave. And I'm really sorry about it, because this is a great moment. Società Geografica Italiana, which has been here since 1925, has always studied the expansion of human beings in different spaces, different places, when different cultural groups which express different research and exploration were going ahead. And so since exploration today is towards some special inner spaces of our planet, such as ocean bottoms and caves, there is an era of exploration which goes beyond the cradle of humanity, which is the Earth. And so, of course, Società Geografica is very interested in understanding what are the future sources of explorations, of course, which we've been following with great interest, but especially those who make them, and so space agencies, aeronautic engineering, aerospace, engineering, but especially the implications for human beings. So we're going towards new types of activities, new context in which we already operate, and communicate is at the basis of everything, because in the capital, those who made more exploration from the point of view of new context, the 117, which lasted 3 days, by collecting rocks and taking samples, breaking rocks and taking information and leaving equipment, or the exploration of opportunity, which was on Mars 24 hours and 24 by sampling, studying, etc. And of course, since there was no human being doing the exploration, everything was based on the communication, data collection, and the capacity to develop explorations. And so the youth is very interested in this paradigm, and so for some time now we've been trying to think of a mesogeography, so a geography which goes beyond the Earth. So as I said, we'll have to leave, but there are two isogeographers here in the room. Professor Fossa Giordano is coming, and the other one is Corrado Giustozzo, who is one of the founders of isogeography, and is a very important witness, because we connect, and this is another important element. Geography has always been a synthesis discipline, and so it must talk to different types of knowledge and sciences, going from social and life sciences to future sciences, and so it must be able to talk to everyone and everything and find languages to find a common understanding. And so for sure these are important, this is an important food for thought. And so I will leave now, but of course I will watch the recording, and I will disturb some of you, because I believe that for us it's very important to have this event here. Thank you. Thank you so much, Professor Casagrande. So I don't know, but of course these geographists are really excited, and now when we meet the geographists in the room, in the street, we will say, okay, I will have to talk to you because you talk to everyone. So one of the speakers is late, but here we have Maurizio Goretti with us, General Director of NAMEX. Thanks to whom this event is taking place, and so I'd like to invite here on stage Maurizio, who will tell us the reasons for this meeting. Good morning, everyone. Welcome. So my task is to welcome you all as the organizer, and to NAMEX. I exaggerated a bit, because I believe that everything was done has been the result of the teamwork, which has seen the participation of the internet service provider. I'd just like to say a few words on NAMEX. NAMEX is a mysterious object for some of you, but not for many. It is an inter-exchange point. It was established 30 years ago. Thanks to 4 Roman providers in Rome, and in this moment it is present also in another 2 Italian cities, Bari and Naples. We have a collaboration with Albania, Kosovo, and North Macedonia. What NAMEX wants to achieve, is to use a part of the profits following its activity. NAMEX is a not-for-profit consortium, and we want to achieve the so-called internet culture. We want to start and talk about some topics which have an impact on our society and which are the product of the things which the internet service provider that represent Namex do every day. And so the organization of this workshop is one of the things we have been trying to do. 3 weeks ago we organized another workshop which concerned another topic, so the streaming on online sports event, which was very successful, and until we see interest, of course we will keep doing what we do. And so I just like to wish you a fruitful workshop, and I'd like to give the floor to the other speakers. Thank you.
Excuse me, what do you think of the news?
I think it's fantastic.
Say the year 2000. I think it will be completely different. In fact, it may not even exist at all. I'm thinking of the incredible breakthrough which has been made possible by developments in communications, particularly the transistor and, above all, the communications satellite.
I think it'll be people will be regarded more as statistics than as actual people.
Immagine molto
è capovolta, l'immagine ci arriva capovolta. Ci arriva capovolta.
And what about this internet thing? Do you know anything about that?
Sure.
What the hell is that exactly?
Well, it's become a place where people are publishing information.
Right.
So everybody can have their own homepage, companies are there, the latest information. It's wild what's going on. You can send electronic mail to people.
I think the potential of what the internet is going to do to society, both good and bad, is unimaginable.
It's just a tool though, isn't it?
No, it's not. No. No, it's an alien life form.
Hello, my name is Hema. My question is, do you have internet in space, and can you take your iPods or iPads to space?
And mix them as you do so, and then set light to them, you get that.
We have liftoff.
Top. Allumage 2 ESR, décollage.
So the good people say, show don't tell. This is a video which has crossed 100 years. Starting from Milieu was thinking of this moon in 1909, and then the interviews of the BBC to the people in the street when the first man went on the moon, and then child when he was asking about year 2000, and he said maybe people will become numbers, statistics. So it was 1966. So I've taken about the arrival on the moon, a part which has never been shown. So the image is upside down, and then it was everything was changing, and there was the narration of the things which were happening at the time. So at the time, people, not everyone had a TV, and so they had that image on the moon, and so it was a direct connection with the moon, which we have never seen afterwards. So what we saw is what actually happened, and so internet came, as David Bowie said. It's not a tunnel; it's an alien life form, something which we don't know what will be. Bill Gates was more pragmatic because he knew what the technological progress would be. And then we went to one of the most important scenes in the story of TV, the launch you saw. I need to apologize with the BBC. I interrupted it to show that launchers no longer leave from Cape Canaveral or Russia, but from China, the French, Guyana, and many other places. And of course, the different panelists will tell you more about this. So before introducing the next session, I'd like to show you a few images just to show you how things happen. So things happen not by chance. So this is an image which was created with the let's say preliminary artificial intelligence. So it was a joke. So Namex Lunar Internet Exchange Point. But what we didn't predict is that behind the post that many people considered a joke, well, not many others didn't consider it a joke. So they started to tag themselves. We have a LinkedIn of an international community, and especially abroad, they started to tag and said, "Oh, have you seen what they can do in Italy?" And so we said, well, maybe this can be something real. We don't think anyone set a data center on the moon, at least for now. But those who come, so the different panelists will tell us about it. Will we have a data center on the moon? Will we have a data exchange set on the moon? Will we do that? I don't know. But we will have here a facilitator who's a journalist, who's passionate for space. You see him everywhere. He talks about the space everywhere. We'll have him with us today. And so I leave the stage to Emilio Cozzi, and I wish you a good roundtable and workshop on the space. Thank you.
Good morning, everyone. And after all these words, and after this video that was summarizing the ideas of Bill Gates, Boy, the moon, and Goretti, actually, I hope that what I'm going to say will have sense, at least that it will be interesting. But let me tell you that maybe it was a joke. But in actuality, Italy and Europe on the moon, and about communication and internet infrastructure, actually, they are thinking about all these things. And in a few moments, we will hear from people who are responsible for those programs. So, welcome back, because we already talked about space in June, and the interest of Namex for this sector is not an exception. But there is a systematic and a systemic interest in this sector that represents not only the future, but also the present. And we will try to talk about this today, because you have seen a series of launches today, and I want to give you a few data. October the 4th, 1957, a metal ball was leaving into the space, and it will be the first artificial object made by the men, so the Sputnik of the Soviet Union. Starting from then, we have sent more than 21,300 objects in the space. As of today, in the different orbits, 11,000 are active in the space. Very well. So now a small detail, and I would like to tell you about the increase of the frequency of these launches. In the last 5 years, we have launched in orbit more compared to the previous 60 years. Starting from 2021, every day, we overcome the record of objects that we launch every year. And this year, we will overcome the previous record. A good part of the satellites are used to offer services and telecommunication application, so navigation services, that will be useful to provide telecommunication services and navigation services, so the timing, as it is said, from the moon. So today, we will talk with the people who imagine this type of programs and with whom is realizing and putting into place these programs. So I would like to invite on the stage our first 4 guests, and I will ask them to sit, and I will give them a few moments to tell what they are doing in this sector, and then I will ask them a lot of questions. So, because I don't know anything about the sector, maybe I will ask them some difficult questions. But I would like to call on the stage the board member of IPNSIG, Mr. Keith Scott. We can do a round of applause for him.
Welcome on stage.
We will speak in English and in Italian, so if you have the headset, you can listen to the translation. At the end of this speech, you will have the possibility to ask some questions by using the app. So if you use the Amex hashtag space, you can ask your questions, and then we will have time to reply to them. I would like to call Mr. Felix Blanche. Good morning. And I would like to invite the engineer Marco Brancati from Leonardo. Welcome. And the 4th panelist is the Vice President Strategic Planning, Mr. Nicola Pizzolo Russo. Welcome. So at this point, I would like to give the floor to Keith. So, sorry, Keith, pardon my English. And I will give you the floor so that you can explain to us what you are doing, because you are considered one of the pioneers.
Okay. Good day. I apologize. I do not have enough Italian to make this work. I can do English, Portuguese, and a little bit of Spanish, but not Italian. Next slide. So there's Internet Beyond Earth covers obviously a lot of things, and probably hours and hours of discussion upon each one. Do I have control of this? Oh, this click. No? Okay. Solar system internet. The work that I have been doing for the past 25-ish years, first with a company in the United States, started back even before I had graduated and joined NASA Jet Propulsion Laboratory, looking at how to extend networking into space communications. And this is in the context of the civilian space agencies and exploration. The things that are done by private companies in the United States can be largely opaque to us. We don't necessarily know exactly what they're doing for their communication stacks, but the civilian space agencies, ESA, NASA, the Japanese, the Russians, the Koreans, have banded together and formed a thing that is the equivalent of the IETF for space communications, a thing called the Consultative Committee for Space Data Systems. And their motivation was largely return on investment. The space exploration, as you can imagine, it has been traditionally a very small community. It's growing now, but they were very concerned about being able to cross-support each other's missions, to help each other when spacecraft get in trouble, and to provide low-level cross-supporting communications. Traditionally, in the space industry, that has been very much not networked. It has been single point-to-point links to the extent of a single data link layer between the Mission Operations Center and the spacecraft. And they would tunnel that data link layer across the internet to a ground station. There are a set of standards for doing cross-support transfer services that make that happen. But essentially a link between each Mission Operations Center and each spacecraft. And above the data link layer, a lot of the communication stack was custom per mission. Back around even before the early 2000s, late 1990s, we looked at this, and NASA had some success with the rovers on Mars, and it became apparent that what we really wanted to do was multi-hop communications through the orbiter to the rover on the surface. And with that, once you get to the point of having multi-hop communications, you start thinking about networks. And there we had some new problems in networking. The main one being that you could either talk to the orbiter, or the orbiter could talk to the lander, but not both. So the Solar System Internet envisioned a time when we could deploy a specialized type of router onto various spacecraft that they could use for communication back to Earth and with each other. If you were sending maybe ESA and NASA and some of the other agencies were sending orbiters to Mars, so that they could intercommunicate and support each other and get a lot more. With that, you get a lot more opportunities for data transfer back to Earth, and the scientists were very concerned with doing that. And then the notion was that once these spacecraft had served their primary missions, they would keep this communications capability that they had been endowed with, and then become sort of routers in a more general fabric. I have not succeeded in controlling the. Hey, okay. So very broadly, you can think of this as three regimes. There are things that are near Earth, things like SpaceX and Kuiper, now LEO, that are sort of continuous connectivity, relatively low delay, and you can run standard internet protocols there. My history and my focus has been on performance analysis and design of protocols that work in areas where internet protocols become challenged. So times when you have either very low bandwidth, very high delay, or as in the case of the exploratory protocols, times when you just don't have end-to-end connectivity, but you may have piecewise connectivity, where I can get from one node to another, from the Mission Operations Center to a ground station, say, over TCP/IP, because I'm on the ground and I've got lots of bandwidth and TCP works. But maybe not using TCP and trying to stretch that control loop over a lunar distance, where you've got a 2.5 second round trip time. If we put people on the moon, I could see having relatively continuous connectivity through a lot of antennas. And you can run the standard internet suite probably to the moon. It just won't, it'll work, it won't work well. It won't be very performant, but it'll happen. When you get past that out to looking at them, if you look at the moon as a stepping stone towards putting people towards Mars or other things towards Mars, once you get beyond the moon, that notion of I'm going to have continuous connectivity and a relatively low round trip time falls apart. At the moon, if we put people there are plans to put communication systems orbiting around the moon to give us good connectivity, maybe even to the backside of the moon. But it's much, much more difficult to do that the further out you get. So getting to Mars, it's much more costly, much more risky to try to put something in orbit there. I'm still not winning on this. SSI technology, I'll go through this quickly. We can talk about it more later. You've got delays, you've got disruptions that we talked about. The key features of the protocol suite that's been developed there are this notion of long-term store and forward, where you may store data on board an orbiter while it orbits a planet to get to the far side where you can't talk to it anymore, but it can talk to the thing you want to talk to on the ground. This use of multiple transport layers across the path, you can sort of think of the bundle protocol, which is the protocol that underlies this DTN and solar system internet architecture, as an overlay on top of different transports, the same way IP is an overlay on top of different data links. Interesting problems in routing, some of which have been taken up by the IETF as well. And then there's some security mechanisms that are targeted there. IPN-SIG's job, we're working with the folks that are actually developing the protocol. So the CCSDS has a working group that Felix is deputy working group chair of. Also within the IETF, there's a DTN working group that is standardizing the protocols. A lot of the people that are involved in both of those groups are also in IPN-SIG. And IPN-SIG's job really is the advocacy for solar system internet. They're not the ones who are the IPN-SIG organization is not directly developing the protocols, but they are the advocacy there and the sort of the public relations arm to explain to the wider public the benefits of DTN and being interoperable. And I think that's it. There's one more slide.
Grazie a Kate Scott.
Thank you so much to Keith Scott, because he has actually talked about a topic on which I will ask some questions. And now I would like to give the floor to Felix Flange from the European Space Agency.
Okay, thank you very much. Good morning to everyone. Thank you, Keith, for the very nice introduction. Maybe just one addition with my head of IPN-SIG on. So IPN-SIG is a chapter of the Internet Society. So basically everyone who is interested can join this chapter, the IPN-SIG, and they also do a lot of training, academy talks, and so on. So if you would like to learn more about this, please join the IPN-SIG. Now I will talk more with my ESA hat on. I will talk about advancing solar system, internet, and ground. And I would like to start, if this is moving. Yes, I would like to start with ESA's vision for the solar system internet, which has been a result of a report issued by the IPN-SIG on governance and architecture of the solar system internet, which reached our Director General, and as a result of this, an interdirectorate working group has been formed, which came up with this very nice vision. I mean, you can read the vision yourself. I think there are several very important aspects in this, and I think it also relates well to the internet, Cultura de Internet, as mentioned by Maurizio. So we're really looking into an interoperable infrastructure. We are looking into having commercial but also institutional elements. We are looking into international coordination and cooperation. And maybe in addition to what we have in the internet today, we are also looking not only in communication but also into navigation services, because for space it makes a lot of sense to look at these both type of services together. And this vision, roughly released 2 years ago, it had a real impact also on a quite high strategic level of the agency. So we see Solar System Internet, we see related strategic actions identified in ESA Strategy 2040, which is, let's say, the highest level kind of strategic document of the agency. We also have a Technology Vision 2040, and there we managed to have a dedicated theme on Solar System Internet, communication and navigation systems. And this has a real impact because upcoming study activities will orient and align with this ESA Technology Vision. Of course, the agencies has already various activities which deal with communication, which deal with navigation. And so one idea of the Solar System Internet is really bringing these different activities together to have a much higher level of coherency between the different activities. So today we already have a network of 4 deep space ground stations providing connectivity across the solar system. We used to have many more small ground stations as well, but roughly 10 years ago, we basically sold this ground station because we see for low Earth orbit and Earth observation missions, these services can now be provided commercially by European companies. We have a program like Moonlight, and probably the colleague from Telespazio will talk more about Moonlight, for providing navigation and communication services around the Moon. We expect to have something similar in the longer term around Mars. We have the Marconi Lightship 1 project, where we start with the first electric propulsion tug to bring other spacecraft to the Mars, but then the Lightship will stay there for providing communication navigation services. Even today, we operate as the first interplanetary network together with our colleagues at NASA. So we have 2 European spacecrafts around Mars, which are really essential for data return for the NASA rovers on the Martian surface. We have projects in the telecommunication area like Hydron. Hydron is to provide kind of optical fibers in the sky, aiming at terabit per second connectivity. There's a first demonstration project now being undertaken by the agency, which will consist of 10 LEO satellites with optical inter-satellite links, optical links back to ground, links to a Mir satellite, and there's an idea of even extended this with a GeoNode for providing interplanetary connectivity. So you see there are a lot of activities going on in this area already. So the key technologies, we identified 3 key technologies. One is PNT for autonomous navigation to increase spacecraft autonomy, no matter where the spacecraft is in the solar system. Of course, communication technology, RF, is a very major technology. We are looking more and more into optical technologies, not only for inter-satellite links, but also direct to Earth. Early this year, we demonstrated optical communication from the NASA Psyche spacecraft more than 300 kilometers away from Earth, 300 million kilometers away from Earth, back to European optical ground segment. And of course, disruption-tolerant networking is one of the key technologies. Let's see. So this is also kind of delay-tolerant. So for disruption-tolerant networking, we are working on these technologies at least since 15 years. So we identified use cases for high data rate downlinks, where we see actually the interesting part is we have very high data rate downlinks now, 10 gigabits per second or even more. And as our ground stations are usually in remote locations, it is very difficult to match the space data rate link rate with the terrestrial data rate we have available. We have use cases for resilient communication and of course lunar and Mars communication. And as a result of this, we see DTN network communication services in LunarNet, which is a specification, the international specification for communication services around the Moon. We see it in the Moonlight program. We consider for the Lightship 1 Mars mission DTN protocols. We will probably have an optical demonstration payload on this mission as well. And we also consider DTN protocols for high-rate data downlinks for the upcoming Sentinel next generation missions where we have corresponding studies currently ongoing. ESA itself is very active in research, development, and standardization of these protocols. So we have activities on bundle protocol quality of service, on bundle protocol reliability, multicast, anycast. We define DTN reference scenarios to stimulate research and development in this area. We have ongoing activities to implement high-rate nodes for ground stations, targeting 10 gigabits per second. We have activities for optical ground networks, where we use DTN for data distribution. We have cloud-native implementations we are currently funding. So again, you see there's a lot of things going on around DTN at the agency. In the broader context, we recently completed an SSI pre-phase A study to look not only at the technologies we need, but also to look into the strategic and economic dimensions of a solar system internet for Europe and the agency and its member states, the industry, to see the potential of these upcoming technologies. We have run a first design study for an SSI Node 1 cislunar pathfinder, which would also demonstrate an optical trunk link from Moon back to Earth, implement DTN technologies, implement deep space technologies for navigation. So we will continue with the definition of this SSI Node 1 Pathfinder mission. So we hope to be able to fly it in the not too distant future. In general, I would like to conclude to say, as the agency, one of our main goals is really to support the industry in the member states. So there are various activities we are currently doing in this direction, but we are also planning to do more activities in this direction. So if you're interested in this, please come talk to me or look into this website to see how to do business with ESA. Thank you.
Grazie a Felix Flange.
Thank you, Felix Flange. Now I give the floor to Marco Brancati, Leonardo of the Space Division.
Allora, buongiorno a tutti.
Good morning, everyone.
Ho pensato di intrattenervi
So I've decided to entertain you for a few minutes by trying to recall, starting from the name and title we gave to the conference, what was and is the contribution which Italy gives at the idea of a global internet. And so, in substance, an internet made of a nerd and satellite component. I'm saying that by referring not to my current role of the technical division of Leonardo, but as a technical director of Telespazio Group. I don't know how many of you had the opportunity to know Telespazio, how many of you had the opportunity to visit the space center in Fucino of Telespazio, which is in Abruzzo region, not far from Avezzano. I'm saying that because it is a space center which is made of 175 antennas of different sizes, which point at different parts of the sky, but it is one of the points on the Earth surface where we can see this connection between the Earth telecommunication and satellite telecommunication, and so we can touch the concept of global cloud before seeing what is going to happen on the Moon, Mars, and the other planets. So the first time I visited it was when there was the Champions League match. It was not a good evening, but anyway, what I want to say is that one of the first European stations to be connected with the American ARPANET was a Fucino antenna which was connected to Pisa. The ARPANET is actually the progenitor of the current internet, which was established in 69. In the space, several things happened in the 69, but this connection took place in 1986 through a connection with a satellite which landed on one of Fucino antennas, and then it was transferred. So I'm saying that because already in that situation we could understand how much the space component and the connectivity coming from the space was important to ensure a Earth connectivity. Then, of course, after that, the technological acceleration was great and very fast. And today, in a different industrial configuration with Leonardo, which established a space division this year by leveraging the industrial components. If you know the sector, the old Officine Galileo. So by leveraging the joint venture Telespazio in Thales Alenia Space, today one of the goals of the division is to create end-to-end systems, and so from the needs of the client to the creation of space systems, ground component and space segment component for services aimed at observing the Earth, telecommunication, navigation, exploration.
In un passato ancora recente.
But these services, which were separate and distinguished, I mean, the world of Earth observation was based and is still based on individual satellites, or not many satellites in a constellation, but satellites which talk to the Earth only. But today, for example, the new constellations, and this is one of the activities on which Leonardo is involved, provide that among the satellites that observe the Earth, there is the possibility to have a dialogue in very high frequencies, optical band. And so this gives us an idea of how a telecommunication in the space segment is functional to allow for another type of service which occurs with very limited delay times. But what must be the consequence of this? The possibility of conserving in the orbit a part of the data which are collected. Not all data will be transmitted on Earth. Many of them will be processed on the orbit in order to transfer to the Earth the most precious and refined information, because if we make observations with different types of instruments but in the optical band, if the service is covered by clouds, the observation is useless, and so these data occupy useless space. But also to make correlations. And so what's the idea? The idea is to create constellations which have a processing and storage capacity on board, but also to create telecommunications which can process and store on the orbit. And so this is a new element which moves a bit the relevance of data center on the ground to the data center of the next future, which will be on the orbit, low orbit. Then we'll see what will happen. So dynamics image is perfect, I have to say. But of course, Nicola will talk about it. So if we take into account the proximity between the telecommunication world, Earth observation world, and navigation, which is transversal. If we take into account the greatest importance of the operation on the orbit to extend the average life of the satellites, if we take into account, and this is another element which is very important for Leonardo, if we take into account the higher proximity between the world of space and the world of defense, because of all the events occurring at the moment, the role of Italy is very important. So the role which Italy had and still has is very important, because we have a complete chain, and the world of telecommunication applied to the different sectors today more than yesterday will have an additional strength if we think of the new protocols, especially the say IG, which will provide for the satellite and the use of telecommunication satellites as native nodes of a global Earth and space network. Thank you, Marco. As for the contiguity between defense and space, we will go back to that, because we heard of Space Shield. You also mentioned Telespazio, and so I give the floor to Nicola Pizzolo Russo. Good morning, everyone. It's a great pleasure and honor to be here with you and have this discussion. So Telespazio is a company of Leonardo Group. It is a company which is active in the so-called midstream and downstream. So it deals with the development of the Earth segment. It operates the Earth segment, and it is active in all the application segments, and so everything which takes place when you launch an object in the space. And so Telespazio addresses all these markets, from the observation of Earth to navigation and space exploration, which is the main topic today. As for the space observation, Telespazio has an important background because it already offered engineering services to support the International Space Platform. It supports, and in 2024 we signed an agreement, a program with ESA, which is Moonlight, which is the Lunar Communication and Navigation Services. We are member of a consortium of European companies, commercial companies, and so I just like to focus on the business model of Moonlight. Moonlight is a PPP with ESA, and so it provides for the implementation, co-funding, design, but also launch, management, maintenance of this satellite system orbiting around the moon, which will provide communication and navigation systems for the next lunar missions. There should be more than 300 missions in the future. Lunar Pathfinder, compared to Lunar Pathfinder, which is an initiative designed and developed, it will be launched next year by SSTL, a British company. The additional component of Moonlight and the CNS is broadband connectivity. We will offer connectivity services and also positioning, velocity and timing services, and so navigation services, which will make it possible, which will make lunar missions to be geolocated as if there was a GPS Galileo around the lunar orbit. So why this need of communication when we talk about access to the moon and the lunar surface? The Global Exploration Roadmap and so the main space agencies in the world agree on the fact that in order to have a station on the moon, we must set some critical infrastructures for sure in production and generation of energy, but also a navigation and communication station. So so from a business point of view, it would make sense for every mission to have its navigation system. This would make the cost of the masses to launch higher, and it would increase the cost of the mission, and so the business case will be unsustainable. But it makes more sense to collect the global demand of the missions and offer navigation and communication services, which will represent a lighter line on a profit and loss account of our clients, rather than having a capex from their end, which will make them never achieve the objectives of the mission. And so, of course, in all that we talk about communication and navigation, blended services, and there are several technological challenges due to the fact that this is a developing market, and I'm sure we will discuss all the different challenges today. Thank you, Nicola. Yes, of course, we will talk about the different challenges you mentioned. So now I'd like to ask my guest to change the program, because I've seen a guest who has just arrived, and so I'd like to invite him on stage, Vice President of Transport and Telecommunication Commission. You have the floor. Thank you for this very important event. I'd like to thank Namex for choosing this place, the beautiful headquarters of Società Geografica Italiana, because I believe it is, if we look at our future and past, we must think of a place in which the vision of the geography of spaces has been built. The spaces on which the geopolitical choices, economic choices, and social choices are made. And so we can extend our view to the space, the domain of the space universe, and submarine space. So today, these aspects are fundamental. They're connected to security, not only from a military point of view, but also from the point of view of the safety of rights. We want to ensure democratically to the future citizens. And so from this point of view, the role of Italy in Europe is a role on which we have to question. So I believe that several insights are being given on what is being doing, but we must also consider the delay of in some scenarios. If we consider the launches in the United States in 2024, more than almost 70 in Europe, and several launches from China, this shows us that we're lagging behind on some elements which are the enabling factors of the access to the rights of the future. And so here we have stakeholders which can play a role, and so we must have public policies which are aimed at strengthening the role of Europe. And so within this, Italy has a great challenge. And so thank you for this exchange. The topic of today is a great topic, and also the place you've chosen is the right and best place. And so thank you, Mr. Casu, for being here with us. So now we can start with our discussion, and we can start from some of the topics you have said so far. So, as I said, Kit Scott was a pioneer in the development of DDN networks, and today this is, we are in a new phase for space exploration, but also space infrastructures. Of course, I'm referring to ENTERNET, and then we will talk about Moonlight, etc. The question for Kate is, what are the key lessons we learned during these 25 years of work? Because you've been working on the DTN since the 90s. And second question, what's the most concrete risk today? Technical fragmentation or a lack of governance? And then, of course, we will have infrastructures which will not speak with each other, and we'll have many problems.
Thank you. So things that we've learned. The space community that we started out working with was and is very conservative about new technologies. When we first started working, there was not the emphasis on small sats. There were no, or CubeSats were only just becoming a thing. And so if you were a mission manager for some mission within NASA, getting a mission was probably the thing you were going to get in your career. It was going to run 10 to 20 years, and failure was just not an option. So they were very much into flying things that had been flown before, things that had heritage, that even if they underperformed or didn't give them back the data rates and the science that they wanted, at least it was something that they knew, and maybe if it failed, they could maybe blame somebody else. So that was a slow start. We then merged into working with the Internet Engineering Task Force, first the IRTF, the research task force there. And again, even within that community, we got a lot of pushback because the technologies that we were proposing were different. Essentially looking at providing storage and intelligence within the network. The first version of the bundle protocol that came out was actually looking at doing reliability within the network and sending acknowledgements node to node and hop by hop as data transited the network. The motivation there being that if you got something from Mars back to a ground station on Earth and you somehow lost it between the ground station and the Mission Operations Center, that you really didn't want to go back to Mars and retransmit that information. You wanted to be able to say, okay, that was lost. Where's the last place it got to? It got to Earth. Okay, good. I'll just retransmit it from there. So we saw a lot of pushback there and spent a lot of time socializing and getting the internet community on board with this new notion of storage and intelligence within the network as opposed to only at the ends. One of the other big things was experimentation and implementations. We did sort of both. We did experimentation and implementation sort of in parallel with a lot of the development, and I think that helped us a lot. It was somewhat difficult not having actual mission parameters to work with, but we were working with the folks in CCSDS and the space community, so we had a good notion of what things could look like. We've got a better notion now, but figuring out what the real requirements were, and now ESA has recently done a lot more work in that area that I think is going to be very helpful as we move forward. There were times when I think some of the specification got ahead of the testing and experimentation. Those tended to lead to problems. So doing that experimentation in concert with the protocol development, I think was really important. There's nomenclature and terminology. I mentioned before the bundle protocol that was developed to support this DTN architecture. It can be thought of as just another layer of protocol similar to IP but running above transport. And that sort of, in the beginning, that caused a lot of people to look sort of sideways at it, to be confused about what it was really trying to do. But really the notion there is that by running over different transports in different legs of the network, you can do the right thing for the local environment that you're in. And we were thinking that we were going to be dealing with possibly very different environments along the path. If you think of something that's transiting Earth, going from a scientist at a university to a space agency to a ground station, all of those communications can be over the internet. Everything, we can use TCP/IP, everything works fine. When you get to that ground station, all of a sudden things change dramatically, right? I've got a 4-minute one-way light time to Mars, and that's not really my problem. My problem is that I don't have antenna time until day after tomorrow. So my data is just not going to make it off Earth immediately. So having something that is able to adapt to those different communications regimes was very important. We ran into all the same problems, oddly, well, maybe not oddly, but we ran into all the same problems as developing IP, except that we had a heads up on some of them. Like, what are we going to do about security? We had a notion of building security in sort of from the beginning, and now we're working through some of the growing pains of causing that to work together with some of the other technologies that we need to implement. But security remains very important, and it's slightly maybe more capable, more flexible in the protocols that we've designed, so that you can have different security mechanisms applied to different parts of the data. And we thought that that was important in order to be able to maybe share data more widely in a general sense without revealing sort of the specifics, and possibly also to support some of the routing decisions that we were going to make.
Ecco, vorrei proprio ripartire da quest'ultima parte della
So I would like to start from this last part of Keith's answer, and I would like to ask Felix Flange first, because we were talking about the first phase of something that will or can become Moonlight. Is Europe starting to build a moon internet? And if we will not develop standard protocols, so for example, if we have China, Europe, and United States, if they will have different protocols, considering that we have some internet entrepreneurs in front of us, which problems could we have in the future?
Yeah, so I think for Europe it's extremely important to have something which is interoperable. Yeah, so the biggest challenge I currently see is that there might be big players or nation states who would run their own protocols, have their own constellation, have their own infrastructure. And for Europe, as I've said, I think it's very important that we work on standards, and we have most of the standards ready, so the standards are mature enough to be deployed, and to have really an interoperable infrastructure. Yeah, this allows also smaller companies to build products, to build services, to participate in this. And I think we have a very rich ecosystem in this area in Europe, but we have to be very cautious that this will not be kind of that we will not end up in a market which will be dominated by one or two big players. I think we are also at a point now which is quite a decision point, because for the first time we are starting to build infrastructure, dedicated infrastructure for communication beyond Earth's orbit. So we have the experience from Mars, but from Mars it's scientific missions which do additionally relay services, and the way they do relay services, it's not really kind of standardized because it came on top and sometimes relatively late in the program with initial missions. So this is now different. So there's a danger that we kind of say, okay, let's try to cut some corners and do something which just works and we can demonstrate something, but I think that's not the way to go. So for ESA, I think it has been a major step forward to require the use of disruption-tolerant networking in LunarNet, and I'm not sure how happy our industry was with that, because we have a chicken and egg problem there. We have the problem, we don't have infrastructure supporting DTN, so there are no missions adopting DTN. There are no missions adopting DTN because there's no infrastructure. It's a similar situation we have with optical direct-to-earth communication. And I see the agency as really in the responsibility to kind of break the cycle. So this is why we said DTN is important for LunarNet. DTN is important to implement, to offer this to at least the agency missions. And at the same time, I'm going to our mission say, look, this will be offered by LunarNet, so we should really consider implementing this. But it's very difficult because, as Keith said, missions are usually really targeted on their scientific purposes. And they're very conservative, so it's very difficult to introduce new technologies into this, but I think it's important for Europe, for our industry, that we do this step because things are changing in space. And I think another aspect mentioned by Marco, quite important, is also for Earth observation. We traditionally operated with dedicated infrastructure. Okay, we shared maybe ground stations for several satellites for data downlink, but now with the constellation in space, we have really a new opportunity to have something which is always connected or almost always connected to really decrease the latency in data return. And I think this is another aspect Europe really needs to look into much more in the really next years.
Grazie Felix.
Thank you so much. Thank you, Felix, for your considerations and your ideas. And I would like to ask a question to Marco Brancati. Marco, Leonardo is very important for Italy, and Italy is in a very important European context where Italy reiterated its interest for space. But we have to say that Italy is a little bit late compared to other countries on some topics. And we were saying in the United States there were 138 launches in 2024, but in Europe there were 68. So what is the situation of the communication in Italy compared to China, compared to the US? So maybe Italy could be a bridge, a hub to do this technological improvement and to become important in this situation. So in order to reply to your question, we can think about two things that are very different, but they can converge. Because for sure, we know not only about the space and space technologies, that we know that in these last years, Europe has realized that has accumulated a technological delay compared to the big actors of the East and the West of the world. And of course, at European level, Italy is aware of it and wants to do something about it. So it's starting to work to create some industrial works so that we can recuperate part of the delay that we had. And let me say that if we think about the space, Italy for sure can play a very important role. I'm not going to say a referee role, but a bridge role, because we know that history of space in Italy is an important history that is acknowledged at global level, because it started from the collaboration with the United States. Of course, the first launches and the first satellites of Italy, I was talking about ARPANET in the past, but we can also think about the role of the global space infrastructure. The space has produced two elements of the ISS and has developed the Cygnus which are the elements that allow the logistics and the refurbishment of the objects and whatever is needed to live in the space station. So in the creation of the lunar gateway, more than 50% of the project has been developed. So we can say that from this point of view, we can play a very important role. But we also know that the relationship with the Middle East is not a very developed relationship in general, even if in other areas is more developed. But if we focus on the Western world, there is the idea and the conviction that we can play an important role to recover our industrial skills. And talking about industrial skills and competences, I was saying that today the new trends are cloud. We have talked about the intersatellite links, so high-frequency optic connections, and we're talking about safety. Today, we have many small companies that represent the Italian excellence on this technology. For example, the optic frequencies and the devices that allow constellation to have satellites that can talk to each other. So we have these excellences in Italy too. We need to look at the transportation layers. And there's another thing that we have to consider, because we have realized that up to a few years ago, all the space realizations, they required a very industrial, long process. Today, as the effect of the new space economy, we have realized that if we have to qualify the objects for a life on orbit for 20 years, it doesn't have sense because the costs are too high, and the technologies, they allow and they request some renewals. So the objects that we have and we put in orbit, they will have a shorter life. So all the components of the automotive world today, they are used to create some space systems. This is the industrial national approach, and it is evolving. I would like to underline the digital companies in the aerospace sector. One is here in Rome, and it was opened last October. There's the Architect in Turin, another one in Bari. They have opened these infrastructures, and they are connected with the infrastructure of Rome, of the TAS, the Italian Space Agency, and they are connected with other small companies that maybe do not have the possibility to have their own infrastructure, but they can use these big infrastructures. So there is a very consistent and continuous ongoing movement to boost this recovery. It is very clear, and so the space can actually help businesses. But let's go back to the moon. We have said that moonlight first thing, moonlight market will be a European or a global market. So the services will be just for European or for the global users. And which are the risks? The risks of a non-interoperability between the different protocols, since we are speaking to entrepreneurs. I can say that Moonlight is a European constellation for the global market, and the key word is interoperability, because we are talking about a business model, and public and private sector are investing, they are taking some risks, but they're also dealing with an emerging market. We will not have any reason to reduce our possibility with some European missions or other space powers that are close to the European Space Agency. Our goal is to access to every market. All the space agencies and all the players that want to go to the moon. And we are also available to go and do that on the European market, starting from a business consideration. Regardless of the infrastructure that will be launched, I don't think that there will be just one infrastructure that can redirect all the users, that can vary on the location. So I think that the only way is to have a collaborative and coordinated approach, so an interoperable approach. Which are the risks? There are many risks, several risks, regarding the development of the lunar economy. And if there's no interoperability, I don't think that there will be standards that could be shared. The first one could be the collision risk. So if there's no data exchange, or they're not efficient, the first thing that happens is the increase of the risk of the collision. That means more warning, more costs for the corrective measures, so the costs will increase, more people will have to work, and this can create the difference between being sustainable or not sustainable from the economic and financial point of view. For example, in a case of collision, we will have some debris, and then the moon surface will be in a very complicated situation. In this case, we will have more risks of more collisions, and then the lunar surface will be inaccessible. Another example is that if we will not have the possibility to share some standards, there will be a congestion of the radio frequencies. And in this case, we will have problems with the services that we offer to our possible users, and the models of Moonlight will be at risk. Apart from the fact that the person that wants to communicate with the different systems will have to have different hardwares and different softwares with an increased cost. So this leads to the fact that we need the interoperability. It is necessary to continue with this type of operation. Thank you so much for your answer. And I would like to ask at least 3 questions, so I would like to ask you to be very, very quick. But I would like to tell you that you can also ask your own questions to our speakers. So I would like to start again from Keith. There were people that understood how internet could have been important in the past even. So the network, but the result is that today datas, they represent the modern value. And I think that the same will happen in the space. Data will be very important. They will represent an economic value, but they will be data to be protected. So how can we find a balance between the data control, protection of data, and commercial development? Maybe we will need a Geneva Agreement, maybe we will need the United Nations to intervene. How it will work?
This has been going on for a long time, right? As I said, with space exploration and the civilian space agencies, it turns out the scientists are extremely protective of the data that comes back from their instruments. Traditionally, you would have a spacecraft that might have instruments from a number of universities, that was sent, say, to Mars. And the scientists that funded and provided those instruments are very, very interested in being able to get a hold of that data first and to be able to publish first, because that's what they're after. So we will continue to see that type of type of architecture going forward. There are mechanisms that we can use to safeguard data from one another. There are security mechanisms. In terms of Geneva Convention or operations mechanism, there are a number of efforts ongoing within both the IPN-SIG and also separate efforts within NASA looking at how governance of the overall SSI will work. IPN-SIG has got a document that's on their website that talks about governance and what's involved in providing a multi-stakeholder kind of environment in which companies and universities and governments can all play together and be able to share the infrastructure. Just a quick note on interoperability that we've talked about a couple times now. I think that's key. The same things that motivated CCSDS to start working on space internetworking in order to achieve an economy of scale are still, I think, critical on the moon. The moon is much bigger. It'll be a much bigger market. But still, if you had N different communications mechanisms for the moon, then you're going to end up having N squared gateways to talk between them. And that just gets unmanageable very quickly. Whereas if you've got a standard, at least you can exchange data at some level and worry about everything else later.
Perfetto. Felix, rimarrei sempre in questo contesto, cioè parliamo sempre di sicurezza.
We are still talking about data protection. What is the vision of Europe in this sense? And we are creating this collaborative framework. I would like to ask, why is it so important, the connection from the atmosphere? I think that we took that for granted, but it's a fundamental point. Why is it so important?
So I would first like to maybe answer about the data and security. So it's clear security is becoming more and more important, and we also see really a shift in the attitude of our missions towards security. So a few years ago, we were mainly talking about should we apply security or should we not apply security, and typically mission was saying we don't need security, we have open data. But this now really changed, so now we are more in a discussion how to apply security. Also in the context of Moonlight, we are thinking, is it user end-to-end security? Is it multi-hop security? It's probably both together. So this really changed a lot, and we are committed to build also a secure infrastructure. We see also a kind of institutional role in this. So we think about certificate authorities, similar like we have in the internet, to really base security on a common infrastructure probably provided by an institution. Similarly, we are talking about other data. We are talking about data about orbits, about collisions, etc. Another important point where we already have a space safety program to address these issues. And this is becoming even more important than the interoperability on the data layer. Maybe also related to Moon, also an area where I see more kind of institutional role is related to lunar reference time and reference frames, where we think an agency should be in a position to provide operational services on this for the benefit of all players in the market. So there's a lot of data, and we always have to think what is the kind of data which is maybe commercially sensitive, which is basically provided by or needs to be protected privately, what is the data which should be shared, controlled by an institutional player.
Perfetto, grazie Felix. Allora chiedo a Marco Brancati.
Thank you very much, and I would like to ask now to Marco Brancati if you can talk about defense. of this data. So the data center in orbit, what does that mean? So when we talk about objects that are in a low orbit, we're talking about objects that we can see from the Earth, that they rise and then they fall. So that means that the time of the visibility is reduced, and this is the reason why with satellites that are in the same orbit, they have the possibility to talk between each other with the reduction of the work of the antenna on the ground. But we can see them for a few minutes, and that means that those objects at the same time, they are very difficult to reach. So that means that if one of that object is a space data center and is playing the role of the data center, there is a slight difficulty to intervene in a non-authorized way to the same infrastructure. So this explains the reason why today we have realized that in the defense sector, so for the protection of information and private data, a data center with these characteristics could be actually more safe and secure than other data center on the ground, on Earth. There are other people that are talking about data center under the ocean. And before we heard about the underwater space, because the expanse in this sector has increased, actually. So this is my idea to provide you with some information, because I don't want you to think that I'm crazy, right? But the technique to access data center, of course, those techniques can be reproduced at space level. I also have to add something else regarding interoperability, because the interoperability concept today is at the base of the position of Europe, because it is very clear that any space infrastructure, if it is realized or made by just one country, can have a certain dimension. But it's different if we have a federation. But the federation can include projects and can also include shared standards. This can happen on the ground too, and this is one of the objectives that we are trying to reach with Telespazio, so the creation of a new ground infrastructure for new control centers. So, Nicola, you said that Moonlight is an example of a partnership between the public and the private sector. So, what will be the role of small actors, small entrepreneurs? So, Moon can be the gateway towards Mars, but actually it has a lot more to offer, because in every European Space Agency or World Space Agency, we are interested in going to the moon, but the objective is to stay on the moon. The interest is to extract resources from the surface, so hydrogen and oxygen that can be used to create a propellant, and that will be convenient to fuel some space vehicles in order to send the fuel from the ground. So this is one of the possible applications that could actually ensure interest from the private sector. But apart from the legacy player, we also have small and medium companies. In order to create this infrastructure, even with the support of the public utility, we need big investments because we are expecting a special contribution from the startup and in the creation of services with a high added value. In this way, we can create business that will allow to produce some benefits, not only for the lunar economy, but also to have some revenues and some return on the investment on the ground. So there is like an intersector spillover to create value, not just for the space sector, but also to other sectors. I would like to remind you that with the Polo program, we have produced some patents and some licenses that have resulted in, for each dollar, like in $4 or $5 for the economy. So let's think about what we go there and what will happen if we stay there. Okay, so you talked about pioneers, you talk about the moon, and Nomex, because this year is the 30th anniversary of Nomex. So now I have a question for all of you. Today, who are the pioneers of these sectors? Maybe new startups, new companies?
Sì, assolutamente i pionieri, in realtà questo appunto lo spazio ce lo insegna,
Space
è qualcosa che in qualche modo ha visto
has taught us that it's something that can unite us, and it requires the collaboration not only of the regular players, not just small players or big players, but every player that is funded by the state, by some sort of capital, interoperability, cooperation, coordination, and market scalability. These are the conditions in which every actor from the space agencies and private players can contribute, each one based on their opportunities. But we need to put every player and give them some procurement rules and participation in the value chain that are transparent and shared. Which type of space are we leaving to the new generations?
Il tentativo, diciamo, finora è riuscito.
So, what the big companies are doing right now is that they're trying to learn with the new realities that we are seeing right now. Because it is true that from one side, startups needs to have a way to create a relationship with the big companies. This is true. For this reason, we are trying to start a series of initiatives that will allow us to get to know each other better from the beginning. For this reason, there is a very strong relationship between the space industry in Italy and other companies. Also, other initiatives in which there are some projects, some shared projects, and we need to give some piece of advice to these startups, because in actuality, the percentage of the startups that are emerging in the space industry is about 50% of the total. One reason could be the fascination for the space, but also because of what Nicola was saying, for the fact that technologies today are continuing and are evolving. So space is not just a place for itself, but it is integrated with the needs of life on Earth, and it's also integrated with the perspective of expansion that we were mentioning before. So, Felix, interoperable protocols and frameworks. Actually, could they be used by by the university? So, from people that are not part of this sector, but they want to explore this sector.
Thank you for the question. I think that's quite important to understand the way we develop these specifications and the protocols. As Keith already mentioned, this partially kind of happened in IETF, so there's really open participation. We see also interest from universities, from small companies, basically. Whoever is interested can join that. We have then the CCSDS, which is partially adopting these protocols or developing protocols more based on, let's say, experience from real space missions. There we lack a little bit of industry participation, but we are also working on this. It is important all the protocols we develop, we try to discuss with our industry, and these are open protocols. So once they are ready, they are freely available to be used and implemented. Then we see industry taking the protocols, putting them into products, so it became really kind of the standard way to operate spacecrafts via these protocols. We also do more. We have software available for European companies, European universities, which implement parts of these protocols so they can be used, they can be further developed. They are quite often available under some kind of open source license. And we are also now starting to develop scenarios for communication, because what we've seen, there's a lot of interest in research and universities and development to do things and to do protocol optimizations for space. But a lot of the scenarios, they show to prove the benefits of their protocols. If you look with the space knowledge on them, you think, oh, they're maybe not so realistically. So by making these scenarios easily available, easily deployable for testing, I would really hope that we really also kind of inspire the new generation, that we have educational efforts, that we have universities, that we can really create also kind of research community around these protocols. And this is also a lesson I think learned from the development of the internet. I've looked very closely how it was developed in the 70s, beginning of the 70s, and this was really bringing people together, creating really community. I think we have really the chance to create something like this in Europe.
Grazie Felix, stessa domanda Kate.
Thank you, Felix. Same question to Kate, but from the United States point of view. So LunarNet is something that comes from the collaboration, and so the US point of view.
Okay. So I think that the opportunities for smaller companies to get involved through the architecture that's being put in place both by the NASA LunarNet and the Moonlight program is there, right? I think that the infrastructure part, there's a lot of very difficult work. The interoperability, as we said before, is key for economies of scale, not just in communications, but position, navigation, and timing as well. Looking at how are you going to land things on the moon? How are you going to land them in the right place and not hit each other? So there's already some work there that NASA has done, letting contracts for some of the communications to smaller companies for building out some of that infrastructure. I think that as the economy of a lunar economy grows, if there are things like mining, refining, providing other services on the surface, having that infrastructure makes it much, much easier for smaller companies that only want to do, if you're a mining company that wants to go in and look for helium, they don't have to worry about how they're going to do all the position navigation timing, all the other infrastructure elements that come in. So I think that that's going to be key to providing a framework that those smaller companies can use to go in and do their sort of company-specific things without having to worry about all of the things that are common, right? This sort of using the internet mantra, right? You want to push the common things down in the stack so that those are taken care of, and people that are doing, application-specific things can worry about their applications and make those happen.
Mi ha suggerito con quest'ultima considerazione.
With this last consideration, you suggested one last question, which is not a real question. It is not a real question. I will just ask for a very quick reflection. And last opportunity for all of you to ask questions. So hashtag #NamexSpace on Slido. So Marco Brancati, in this case, the question, and I need a very quick answer, is how can we be sure that the space internet is better than the internet we have today? Well, you're asking me a question in a moment when I had a problem with my computer today. Well, the resilience of the space component is remarkable. So, let's say if we want to make a remark, so if we combine the Earth reliability and the space reliability, the average will increase. Same question to Kelly. Well, similar question, a similar answer. So we need to make a hybrid, so a combination between Earth and space. Keith, same question.
So I think in addition to the interoperability, I think being able to apply security mechanisms at various points in the network and be sure of the peer that you're talking to is going to be really important for maintaining both data integrity and keeping any unwanted traffic off of the network, because it's still going to be relatively low bandwidth.
Ho lasciato Felix volutamente per ultimo perché ci dia
Felix last, because we need an institutional answer from you.
Well, I think the space internet will be in certain aspects worse than the current internet, because we have inherent problems with delays. Yeah, it might be also much more difficult to provide enough connectivity. I think it will be better in some aspects, like Keith mentioned. We are thinking really security. Really from the beginning, we are looking into how internet developed, and we are trying really to learn from this experience. So I would also hope that we will not end up with an IPv4, IPv6 challenge like we ended up in the terrestrial internet. So there are some clever ideas to kind of have also this kind of more evolving, more backward compatible nature within the protocols themselves.
Vi ringrazio tutti e quattro.
Thank you so much to all of you for a very quick answers you gave me. So now you can ask your questions to our speakers, and so I'd like to ask technicians to send here a few questions we have received. So I will start with the first question. So a question to the four panelists. So let's start with Felix, who was the last one. Ming Cherf used to say that internet is for everyone. Are we creating a space internet for everyone, or only closed network for a few operators?
Well, I think this will be there will be kind of transition, of course. Currently, space communication is very costly. But the vision of the IPN6 is really to create an internet for everyone. So, and I think this will be a slow progress. Now we have some more closed networks because we have agencies. We already cooperate with all the agencies around the world to provide access. But I think it will slowly open up all to the more public as well. And the development I cannot really foresee. I asked also Wind some time ago, when you started all this internet business in the around the 70s, did you have any idea what will become out of it? Because I always have the discussion, do we design the SSI top-down or bottom-up? And said, of course, they had no idea. And I think we are in a similar situation for the solar system internet. We are laying a foundation, we need to start, but we will really see what we will get out of this in the long term.
Farei la stessa domanda a
Same
Kate
question
Scott.
to Kate Scott, because for Marco and Nicola, I have another question. So, Kate, are we creating an internet for everyone or only exclusive networks, just for a few people?
It's an internet for everyone. It's going to be, as Felix said, it's going to be closed. There will be closed portions of it. The space agencies are very protective of their assets. We really can't have spam traffic traveling across an Earth-Mars link because it would be a denial of service on epic proportions. But the idea is to open up the communications to everybody, including, not just, well, starting with, say, scientists at universities that are running instruments on board spacecraft. We want to be able to, we want to enable a scientist sitting at their regular desktop or regular laptop in a university to communicate directly end-to-end with their spacecraft, where end-to-end is in this sort of store and forward piecewise connectivity method that I described before. And as that opens up to, first starting with scientists and people that are associated with some of the agency assets, if things go well on the moon, that will open up to people wanting to send emails and videos and whatever else they use to communicate with other people on the moon and conduct business there. So it will be for, the notion certainly is that it is for everyone. The initial build out will probably see some closed chunks as it gets started.
Grazie mille. Tra l'altro io ho fatto
Thank you so much. So I have chosen the questions, and a person to answer. But of course, if you want to answer, you can. So Marco, how can we manage allocation of lunar orbit allocation among the different players if we consider old-fashioned the national regulation? Does the industry have governance proposals? Because we're already splitting the moon and the lunar orbit. Well, let's say that from this point of view, the industry has not raised the issue, honestly. We know that we're trying to regulate so far the access and use of the close orbit, the so-called LEO orbit. We've done it with a national law, through a national law. And so we are going to have implementing decrees. We are doing that at European level. Some other countries have already done so. So it is a progressive process. So I don't believe we will proceed as in the 18th century. Okay, thank you. So other questions, more difficult questions are coming. So another question for Kit. Is there information about the progress of China on space internet and the compatibility of their DTN protocols with ITN-SYNC? Are there other active countries?
So certainly there are a number of active countries. One of the first actual deployments of solar system internet and DTN for a mission was South Koreans. There was an experiment that was run on the Lunar Pathfinder mission from NASA looking at optical communications. We don't have so much information from China, although they are a member of CCSDS and they come to the meetings and have been at the meetings developing the DTN protocols. But certainly all of what you might think of as the big players are there: China, Russia, ESA, United States. But I don't really know much more about China specifically.
Domanda per Felix in particolare. C'è il rischio che il
Question for Felix. Is there the risk that the contribution of the EU to define standards in governance is similar? On the contrary, the commercial exploitation is for USA and China. It's a difficult question. I don't know if Marco wants to say something. Sorry. Well, I recall that today the two great US constellations, Starlink and Cooper, at the moment are moving on proprietary standards, something which Europe wants to avoid, absolutely. So let's say the open standard is a necessary condition to be inclusive. I have to say that in this moment, the choice of Cooper and Starlink is probably precluding them some opportunities. Of course, the commercial opportunity followed by Starlink is evident to all of us. But this is the situation at the moment. Felix.
Okay. Okay, I think the situation with Starlink and Kuiper is really we have proprietary protocols. We don't actually know what's happening there. We know that Starlink is selling optical terminals to provide connectivity via Starlink. So you can buy it there, but it's really closed up. So I wouldn't advise for us using this. Yeah, so we need to have really to be independent. We need to have something which we can implement independently. In other areas, I think we are quite good related to the standards. So it depends. There are a lot of standardization organizations. For communication, we see CCSDS standards supported by the major agencies, including China. So even today, we are able to do cross-support with our ground stations with China based on the standards. Yeah, I think that is really the risk I see, that we have these two big players which put their own equipment, which has a kind of business model to provide everything. And this is what we have to counter with the standardization. And the current state of standardization in this area, I think it's quite advanced, especially for communication. We see a LunarNet, which is really a joint initiative with NASA, with JAXA, where we basically take the current standards in terms of communications and makes them applicable to LunarNet. So I'm less concerned in this domain. We also see big players in the US, by the way, which are committing to the standards.
Prego, Kate.
In terms of governance, as I mentioned, IPN-SIG has developed a governance document that looks at how to build a multi-stakeholder infrastructure around space internet. That's really is a sort of an ongoing proposition. We have a version of that document, but we would certainly welcome inputs from the European community and Italy. NASA also has been looking at governance, largely mechanisms in PNT and less in communications. But I think that they will hopefully release a version of that governance document so that they can get feedback and input. And I think that this is, it's very important. If we certainly need interoperable protocols in order to make this happen. I think the two are coupled, right? If you have a set of interoperable protocols and nobody likes the governance model, they're not going to play. And so we need both.
So I promised a complex question. I left it for the last minute. So this question: do you think that military powers can rule the connections on the moon? But I change it. Since we are talking about the new rush to the moon, those who come back early, or United States, or go to the moon, China, will they have a strategic advantage also for technological standards? Well, in this case, what we call a first lunar advantage as a weight in terms of prestige. But if we start and think of make some reflections beyond the logic of powers, the cost associated to this type of primacy will not be paid back. because that's not the dominant design which will prevail. Having a proprietary system, so in the case of Starlink, we talk about a global population, the possibility of having so an initiative which has such a capital that has returns which make it possible to close the business model successfully. But we are not there on the moon. If there are 10 or 15 or 20 users in the next few years, having all these, a closed system is not a winning point. For political reasons connected to the reputation of the states, from a business point of view, we must be ready, but this will not necessarily have a return on investment. Of course, we need to be ready. Any other remarks on this? Well, Nicola gave an answer connected to the economy world, but we have to say something from this point of view. We need to be very careful, because one of the main objectives of the exploration and the presence on the moon is, for example, the extraction of rare lands, and we know that these are something which moves the balances on the earth, and so we need to be vigilant. Thank you. Felix, Keith, do you want to add something?
Yeah, I think again, interoperability is not only important for economic reasons, but it's also essential for us because it costs quite a lot putting things on the moon, putting things around Mars, building assets on Earth to communicate with that. So this is why interoperability today is a common practice. We daily use ground stations from our colleagues at NASA. NASA is using our ground stations. We are building slowly also more commercial deep space ground station. And it's also an element of kind of risk reduction. Yeah, if you are dependent on a single provider with your lunar mission and something happens to that provider or to the equipment of that provider, you have a real problem. So this is why it's absolutely essential for our exploration missions to have interoperability with as many potential providers of communication and navigation services as possible.
Grazie, Philip. Prego.
So, in terms of strategic advantage of getting to the moon, economically, there will probably be some. If you're the first people there and the first people that start mining, then you'll have an advantage in terms of experience and choice of mining sites and things like that. The issue of governance is huge there, because there are existing treaties that specify who's allowed to, who and how entities are allowed to use resources on the moon and sort of claim areas as theirs, and generally it's you're not allowed to do that. So figuring out how that's going to work and possibly change is going to be a big thing. That said, it will be, since it is a cooperative effort and there's going to be a lot of attention there, it probably would be difficult for one country or even a small group of countries to monopolize resources on the moon, given the treaties and the visibility.
Grazie mille. A proposito di rincorse, pensavo.
Thank you so much. So, I thought this was a critical question, but you were great in your answers. So thank you, Keith. Thank you, Felix, Marco, Leonardo from Leonardo, Nicola Russo dell'Spazio. So thank you all for your presence and for being so precise with timing. So I want to thank Namex. This is just a first step of our journey. So I believe and I hope we will keep analyzing in depth this topic. And so, of course, we have to think of the future. I'd like to thank Società Geografica Italiana, which has hosted us in this place, which is perfect for the journey we're taking. And so see you at the next step. And now we have a light lunch. See you next time.
And thank you very much to the translators.